The theoretical probability or classical probability of an event E is defined as, so probability of an event is given by P of E is equals to number of outcomes favorable to E divided by number of all possible outcomes of the experiment okay. Next, the definition of probability was given by, so the definition of probability was given by Pierre, Simon Laplace in 1795, okay, or Pierre Simon Laplace, okay. So very important question. The probability of a sure event or certain event is 1, is always 1. The probability of an impossible event is 0. The probability of an impossible event is 0. So probability of a sure event or certain event is 1 and probability of an impossible event is 0. 52 deck of playing cards divided into suits of 13 cards. How many suits? 4 suits. Okay. In deck of playing cards, kings, queens and jacks are called face cards. Okay, now next, probability of an event E plus probability of the event not E is always equal to 1. Okay, so P of E plus P of E bar is always equal to 1. Okay, so P of E means probability of an event E, and P of E bar means probability of the event not E is always equal to 1. The probability of an event that cannot happen is called impossible event. That cannot happen means impossible event. Its value is 0. And next question, the probability of an event that is certain to happen, definitely happen, so is called sure event or certain event. Sure event or certain event. So its value is actually probability of an event that is certain to happen is 1. Its value is 1, is called sure event. Okay, now so here is asking value is certain to happen is 1. So probability value is 1 and that event is called sure event or certain event. The sum of probabilities of all the elementary events of an experiment is 1. The probability of an event is greater than or equal to 0 and less than or equal to 1. So very important, probability of an event is greater than or equal to 0 and less than or equal to 1. So this is the condition. Next, P of E plus P of E bar is always equal to 1. So probability of an event plus probability of not E is always equal to 1. In probability, E and E bar, probability of an event and probability of not E, are called complementary events. So which of the following cannot be the probability of an event? We know that probability of an event is always lies in between 0 and 1. So probability of an event is always greater than or equal to 0 and less than or equal to 1. So here 0.7 means it lies between 0 and 1, in between 0 and 1, so this is correct. 15% means by 100. 15 by 100 means 0.15. So 0.15 is always lies between 0 and 1. 2 by 3. So 2 by 3 value is around 0.667. Okay. So this is also lies in between 0 and 1. So here minus 1.5. Minus 1.5 is less than 0. So this is the wrong option. So option B. So minus 1.5 cannot be probability of an event. Okay. Next. If P of E is equal to 0.992, what is the probability of not E? We know that P of E plus P of E bar is equal to 1. So P of E is given. We want P of E bar. So P of E bar is equals to transpose P of E. It becomes minus P of E. 1 minus P of E how much? 0.992. If you subtract, you will get 0.008. Okay. And similar case, if P of E equal to 0.05, what is the probability of not E? Same. So here answer is 0.008. So here P of E plus P of E bar how much? P of E plus P of E bar is equals to 1. Now we want P of E bar plus P of E becomes negative P of E. So 1 minus P of E. Okay. So simply transpose P of E bar, sorry, P of E. Then positive P of E becomes negative P of E. 1 minus 0.05, how much? 0.95. The book on games of chance was written by, the book on games of chance was written by J. Carden. J. Carden. Okay. So mathematician name J. Carden. The probability of an event which is impossible to occur is 0. Such an event is called impossible event. Such an event is called impossible event. The probability of an event which is sure or certain to occur is 1. Such an event is called sure event or certain event. Certain means definitely. Certain event. In the experiment of tossing a coin, number of possible outcomes. How many outcomes? In experiment of tossing a coin, we have only 2 outcomes, head or tail. Head or tail. So number of possible outcomes 2. In the experiment of rolling a die once, number of possible outcomes is 6. What are they? 1, 2, 3, 4, 5, 6. Okay, na? 6 numbers. In the experiment of tossing a coin once, the probability of getting head or tail is, 1 by 2. Answer is 1 by 2. Okay, na? So equally likely events, either we get head or tail. Next, in probability of in the experiment of rolling a die once, probability of getting a number less than 7 is. Probability of getting a number less than 7 is. So what is the answer? So total possible outcomes is 6. Number of favorable outcomes 6, because less than 7 means we have 6 possibilities. Again 6 by 6, you will get 1. Answer is 1.